Welcome to Lesson 7-2, Introduction to Exponential Functions. In this lesson, we are going to look at how to graph exponential functions using a table. So the first thing that I want to discuss is the standard form of our exponential equations. We talked about in our last couple units the standard form for a quadratic equation. Now let's take a look at the standard form for an exponential equation. It is a pretty simple looking equation. It's going to be y equals a times b raised to the x power. And this is something that is on your formula sheet. Now, as far as what each of those mean, a is going to represent our starting value, b is going to represent our growth factor, x will be our input or our x value or domain, just like we're used to, and y will be our output or y value or range, just like we're used to. So as far as graphing an exponential function, we do have an outline of some steps to follow. The first thing we're going to want to do is to choose 5 x values, inputs. When we have chosen those 5 values, we want to plug them into the equation that we're given to give us some y values. We'll record those y values in the table, and then we'll have some ordered pairs that we can graph. Once we have those ordered pairs, we will plot those on a graph. We'll connect the points, and then we will draw the asymptote line. So, we'll start out with your basic parent function of y equals 2 raised to the x power. And we're going to try and graph these. Now, we did say choose to 5 x values, but we aren't going to be as specific as to what values we should choose as we were in our quadratic unit when we were graphing from a table. There we had a very set sort of thing to look for the vertex, the y-intercept, those kind of things. It's going to be a little bit more open when we're graphing these exponential functions. So the ones that I normally start out with to try and graph are -2, -1, 0, 1, and 2. Now, you might have to adjust these from time to time. You might have to try some numbers that are bigger or smaller, or sometimes you might have to graph more than 5 points to really get a good idea of what's going on. But this is going to be kind of our guideline of where we can start with, and then we can work from there using some critical thinking based on what we still are going to need. So I've chosen my x values, and I'm going to plug this into my original equation. Y equals 2 to the x. So I'll start with y equals 2, and I'll plug in my -2. Now remember, when we have a negative exponent, the way that we deal with that is that we flip the base, and we change the exponent to be positive. So instead of 2 raised to the -2 power, that's going to be 1 over 2 squared, which is going to be 1/4, or 0.25. And you can use either one of those answers, whichever is going to be easier for you to help graph with. Remember, you can also plug these values into a calculator to go ahead and figure out what the y value is going to be. So let's continue. Let's plug in -1 next. So I'll do y equals 2 raised to the -1. That's going to again flip over to be 1 over 2 to the +1 now, which is going to give me 1/2, or 0.5. So I'm going to fill that into my chart. 1/2 or 0.5. Again, it doesn't matter which one you go with. Alright, plug in 0 next, since that's the next on our chart. Remember, anything raised to the 0 power is always going to be 1. So that one's a pretty easy one to figure out. We'll go ahead and continue on. We'll plug in a +1 in for our x now. 2 to the first. Remember, anything to the first power is whatever the base is. So that's going to be 2. So I will plug that in. And then finally, I'll plug in y equals 2, and we'll plug in 2 for the x value, and that will give us 4. So this gives us some points that we can go ahead and start graphing. So -2 1/4 is going to be over to the left 2, and it's going to be up just a little bit to be 1/4. We're going to have to do a little estimating there to get exactly where the point is. Alright, the next thing we have is -1 and 1/2. So we're going to go left -1, and we'll go up 1/2. So this time it's going to be halfway between. And you can see we're kind of starting to get a little bit of an exponential curve. We'll go to the next point, 0, 1, and we'll plot a point there. And then we have 1, 2, and we have 2, 4. So this is going to give us a good idea of what our shape is going to be. So I'm going to go ahead and connect these dots. And I'm going to get this in here. Now remember, we talked about in Unit 3 what our asymptote line was going to be. it was going to be whatever was added on to the end of an exponential function. In this case, we don't have anything added on there, so just like when we didn't have a y-intercept in a linear function, we can put a plus 0 there because adding 0 is not going to change anything. So that means we're going to have an asymptote at x equals 0. So I'm going to just draw a dotted line in there. And just a general reminder of what a asymptote line is. It's a line that the exponential function gets really close to, but never actually touches. Alright, so we are asked about some of the characteristics of our exponential function, so let's go ahead and answer those. To start off with, we were asked for the asymptote, which is actually what we just drew that line in for. Remember, we said that it's whatever is being added on at the end. In this case, it was 0, so our asymptote is going to be x equals 0. And actually, that's incorrect. Sorry, let me go back. The asymptote is actually a horizontal line, so that's actually going to be y equals 0, not x equals 0, because we want the horizontal line. Alright, so we also need to look at the x-intercept. Since our asymptote line is y equals 0, our exponential function is never actually going to reach that x-axis. So we're actually going to have no y-intercept, or no x-intercept, so we're going to put none. Our y-intercept remembers where x equals 0 and where it crosses the y-axis. That point was actually one of the points we got from our table, and that was 0, 1. That was right here where x was equal to 0. Now we've talked about domain for exponential functions back in Unit 3. We said that as long as there are no restrictions on the domain will be all real numbers. And we can write that in a wide variety of ways. We can write that funny looking R. We can write it out in words, all real numbers. We can also write it in interval notation from negative infinity to infinity. And we can also write it as set notation, where we go from negative infinity is less than x is less than positive infinity. All four of those mean the same thing. Alright, for our range, if you remember from Unit 3, that is going to be based off the asymptote. So remember our asymptote again was y equals 0. Now we want to look at whether we want all the values above that asymptote or below that asymptote. In this case, our graph is completely above the asymptote, so we want the y values that are greater than 0. Now remember, since we don't actually touch an asymptote, then we are not going to have an equal to line underneath it. Alright, continuing on, interval of increasing and decreasing. This function, remember, we will read increasing going from left to right. So if we were to trace this function going from left to right, we would see that this is a increasing function. So we can go ahead and put that. If it were broken down into two separate questions, it would be always increasing and never decreasing. An exponential function, remember, is always going to be one or the other. Alright, we can look at the interval of positive next. Remember, the interval of positive is based off of when it is above or below the x-axis. Interval of positive is going to be when it is above. Interval of negative is going to be when it's below. If we look at what we're given with this equation, our whole entire line is going to be above the x-axis, since the x-axis was actually our asymptote. So our interval of positive this time would be all real numbers, or always positive. If we look at the interval of negative, however, we don't have anything down in the bottom half of our coordinate plane, so we would say that this is never. Our next question is going to be the rate of change over the interval from 0 to 3. This is one that's going to take a little bit more work. We are going to need to use our slope formula, but before we can use our slope formula, we are going to need to be able to have two ordered pairs to plug into it. So, that 0 to 3 means that we are going to have two ordered pairs, one that starts with a 0 and one that starts with a 3. And we are going to have to figure out what those y values are. So, we did already figure out what our y value is when we plug in 0. If we look back to our original table, we plugged in 0 and we got 1. So that's one ordered pair that we need. To find the other, we have yet to plug in 3, so we will need to do that. So I'm going to plug in y equals 2 raised to the third power. 2 to the third power is 8, so I have my other ordered pair here. Now what I need to do is plug into your slope formula. Remember, this is on your formula sheet. y2 minus y1 over x2 minus x1. This is our formula for slope. So I'm going to plug in the ordered pairs from up above. So I'm going to do 8 minus 1. I chose to use 8 first, so I'm going to have to use my x value that matches with that 8 first as well, so 3 minus 0. 8 minus 1 is 7, and 3 minus 0 is 3. So that gives me a rate of change of 7/3. Finally, the last characteristic that I'm asked about is end behavior. Now, end behavior we are looking at as x approaches negative infinity. So that means when we're going this way on the graph, we're looking at what happens to y. So as we're tracing the graph and seeing where it's going, we can see that as x continues to go to the left, our y value is going to approach the asymptote. Now we said our asymptote value was 0. So we're going to say as x approaches negative infinity, y approaches 0. On the second part of this, as x approaches infinity, that means as we go to the right, we're going to follow our graph, and our graph is going to go higher and higher, and it's never going to stop. So we're going to say that y is going towards a positive infinity. If you think back to our lesson on special characteristics back in Unit 3 and then the following lesson of it. Oops, sorry, we're getting a little update. Let me go ahead and exit out of that. Alright, but if you think back to Unit 3, like I was saying, on end behavior, when we talked about some of the patterns for an exponential, it will always be going in one direction towards the asymptote and the other direction towards either positive infinity or negative infinity. Alright, that is graphing a basic exponential function. There is no you try after this video, but we are going to work 2 more examples together with you, so make sure that you check out those 2 videos.